Hi guys, please support me through PayPal to devinwyndham@gmail.com. Devinwyndham@gmail.com is one word, all lowercase. A 5 kilogram ball, forget the stuff on top. A 5 kilogram ball moving at 6 meters per second on the x-axis makes a glancing collision with a 2 kilogram ball initially at rest. After the collision, the 5 kilogram ball is moving at 4 meters per second at an angle of negative 60 degrees. Find the speed and direction of the 2 kilogram ball. Pause the video, try this on your own. Alright, here's my solution. I think you should enjoy physics. The way I enjoy physics is, notice that I write on printer paper because paper with the rules on it, aka the lines, gets in the way of my physics and my math. Another way I enjoy physics is writing with a ballpoint pen instead of a pencil, because even though I can't erase with a pen, I find that pencils are scratchy and annoying and always getting dull. Another way I enjoy physics, I moved to France when I was 14, and I noticed the French would write their X's like this. In the United States, we write an X as a simple cross, and that can get confused with a plus sign or a times sign, so I frequently write X's as the French do. Okay. Sketches are useful for enjoying physics, so here's a sketch. It's always good to proofread your work. Let's make sure this is an accurate sketch. So 5 kilogram ball moving at 6 meters per second on the x-axis. The 2 kilogram ball is initially at rest. So this is the before diagram. Here's the after diagram. Let's check that one. Kilogram ball moving at 4 meters per second at an angle of negative 60 degrees. I didn't put the velocity vector for the 2 kilogram ball because I don't know it yet, so I didn't really know its magnitude and direction. All right, let us proceed. All right, so instead of just starting out with a lot of letters, I just sometimes find it easier to start plugging in the numbers. So I'm gonna equate my my x components of momenta and my y components of momenta. So here's the x components of momentum. So in the before situation, the only x component of momentum is 5 times 6. So we get 5 times 6. I'm not bothering with units either. Units for me are just getting in the way, so I'm just doing numbers. 5 times 6. All right. The after x components of momentum are, so 5 times 4 times cosine 60 degrees. Notice how I check, always check. 5 times 4 times cosine 60 degrees plus 2, let's just call this v. The v will denote the velocity. VR will denote the velocity of the 2 kilogram ball. So plus 2v sub x. And y components now. So the y component before is obviously 0. The y component after is, so here's my 0. The y component afterwards is 5 times negative 4 sine 60 degrees. So that's what we have here. 5 times negative 4 sine 60 degrees plus 2vy. Right, plus 2vy. I write it with an and, connect those, and I group, it's two statements, a compound statement, so I connect them with parentheses and connect it with this double arrow, which means is equivalent to. I really like this notation. It helps me enjoy physics. This means is equivalent to. It connects two statements that are either both true or both false. All right. Sometimes I don't feel like using a calculator because it takes, I like to get exercised in doing math. Let's just say it that way. So no calculator for me for now. That helps me enjoy math and physics, keeps my mind sharp. All right. So we bring over the 4 cosine 60 degrees, like so. We divide by 2. Zoom in. So I like to keep stuff on the same side, otherwise it's too much mental gymnastics for me. So I move this over, 20 sine 60 degrees divided by 2. 8. So we've got 30 here, 20 cosine 60 degrees. I know that I can do that quickly in my head. That's 1/2. Here's my 2 that I copy. Math and physics is a lot of copying. Don't be ashamed of copying. It's okay to copy. Notice most of my work is just copying what I've done before. That's okay. All right, 20 over 2 is 10. That's how I get the 10. Sine 60, let's think about that. That's root 3 over 2. All right. See, not using calculator helps me keep my mind sharp. You know, I like doing that in my head. Okay, double arrow. Okay, so we're just gonna distribute this 2 in the denominator. So I've got 15 minus 10 times 1/2 equals Vx. 5 root 3 for Vy. All right, the question asked for the, what did it ask for? Speed. All right, so we've got to find the speed. So we're going to take the roots, we're going to take squares. So 15 minus 10 times 1/2 is 15 minus 5. So I've got 10. Square this, you have 25 times 3. Hey, we can see some 5s hiding in there, and they're doubly in there. So pull out the 5s from here, and pull it out. So you've got 5, what's left in here is a 2 and a 2. Pull out the 5s from the 25, and we've got a 3. 4 plus 3 is 7. Notice this is bigger than the velocity we started out with. We started out with a velocity of 6. Root 7 is between 2 and 3, so this is between 10 and 15. So this 2 kilogram mass is really booking it. I thought that was surprising, but it's really booking it between 10 and 15. Wow, interesting. I love it when you get results that are just not like common sense. Like, how could a 2 kilogram ball be moving faster than the initial bullet, the initial cannonball? It's just interesting, isn't it? Really interesting. Hope I didn't make a mistake. All right, the speed of the 2 kilogram ball is 5 root 7 meters per second. We have Vx equals 10, remember, because 15 minus 10 times 1/2 is 15 minus 5. So we have Vy over Vx is equal to 5 root 3 over 10, which is equal to root 3 over 2. So the direction of the 2 kilogram ball is arctan root 3 over 2. All right, again, please support me through PayPal to devinwindham@gmail.com, and please subscribe. Bye.